Welcome to the Picarro Community Green Forum, an open space for thought leaders to discuss the ongoing challenges in gas, energy, and beyond. I'm Tracy Boyd, Marketing Director for Picarro, and the episode you're about to hear is part of our expert series covering methane abatement. Our guests will share their perspectives on where the industry is and what is next, providing important insights into what is fast becoming a new language, the language of methane emissions measurement, quantification, and abatement. Joining me today are Picarro's Francois Rongere, Senior Director, Solution Architect, Climate and Safety, and Sean MacMullin, Senior Director, Software and Data Analytics. I'm going to go ahead and jump right in with the first question. In our previous episode, we discussed the detection and quantification of methane leaks. In today's episode, we'll discuss programs for methane emission abatement. Sean, can you help me understand how these two concepts are linked together?
Sure, Tracy. So as you mentioned last time, we talked about quantification, particularly how we do quantification from vehicle-based sensors. But it's really important to understand that quantification is really just the first step. And so the quantification allows operators to understand emissions specific to their network, but realizing that the end goal is not just quantification, or to be more accurate or specific about quantification, but rather to set a baseline and drive emissions reduction relative to that baseline. So that's really the key. And the first step is quantification. Second step is abatement, because you can't reduce what you don't measure.
Francois, anything to add to that?
Yeah, and it's actually, I would like to add that there are several goals of reduction around, and perhaps starting in 2014-15 through SB 1371 in California, we put a goal of 40% reduction by 2030. Actually, this goal was not formal because we, at this point, they didn't know how to really reach that goal. But there are other goals of the pledge, methane pledge that has been agreed upon in the COP26 meeting in Glasgow a year and a half ago, by 30% by 2030. The one future challenge that also put a goal to reduce emissions below 1%, and actually they reach that goal and they continue to aim to reducing these emissions. So all these goals, and now a lot of gas utilities have goals that can go up to zero net methane emissions. All these goals rely on implementation of programs that will reduce the emissions. So it's definitely not just measuring, but also reducing the emissions.
Okay, so let's talk a little bit about what are the options that are available to distribution networks to actually reduce emissions.
Yeah, I can start with that. So I think it's important to preface, what Francois started to mention here, that what we're talking about here is only part of the solution. Utilities and companies have many different programs to meet their net zero and other ESG goals, but here we focus specifically on how to reduce fugitive emissions from assets within a distribution network, so mains, services, meter sets. So one way to drive emissions reduction is through a pipeline replacement program. And so while this is part of the toolbox, companies realistically only replace on the order of 1% of their infrastructure every year. And so that in itself doesn't bring about enough opportunity for abatement, the sort of range of 50, 80% or more that's going to be required by utilities to reach their net zero goals. So on the other hand, there's a unique opportunity, which is presented by the leak sizes that you see in a distribution network. And so one easy way to remember this is the 5 and 50 rule. So 5% of the leaks are responsible for 50% of the fugitive emissions. And so we refer to those 5% of the leaks as super emitters. And so if you were able to find those needles in the haystack efficiently, you can actually have a very effective emissions reduction program by prioritizing the repair of a small number of leaks, which are accounting for most of the emissions.
The super emitter program, the reduction of large leaks emissions, has two components. One is the detection, the early detection of the large leaks. So you need to have a way to rapidly detect these large leaks. And second, the prioritization of repair. And that's an important thing because without measuring every leak, without the ability to quantify every leak, you cannot really identify these large leaks. And that's what the vehicle-based methane quantification process give us, is the ability not only to measure the overall emission of a system, but also to identify the large leaks directly, which at that point will also help to develop the program for reducing the emissions. So that's very important to have these two aspects, detection and prioritization of repair.
Francois, can you describe for me, I hear this term super emitter a lot. Can you describe for me what is a super emitter program and what's that all about?
Yeah, that's a good question, Tracy, because there are different definitions of super emitters. So it's important to clarify that. So you can define the super emitters as the largest sources of emissions, for example, in the territories. That has been done, for example, by the California Air Resource Board a few years ago and reported by Riley Duran in a recent publication in Nature, where they were looking for the largest emitter in California, independently of the system. So it's not what we are using here because we are focusing on distribution, and the leaks in distribution are much smaller than other sources. There are other definitions that look at the emitter as a function. So the definition of super emitters as more for production, the production sites that emits the most or emits proportionally the most. There was also an interesting article in 2017 or so by a group of researchers that, including Alvarez from EDF, that this group proposed to have a definition with a ratio of emission compared to production as a way to define the super emitters. The definition we use is different. It is a definition which is specific to a group of assets, distribution system for us, and try to identify within this group what are the largest emitters. It's a little bit the same thing as, for example, Adam Brandt has done in an article in 2016 where he says that he observed that for most of the class of assets, about 5%, as Sean mentioned before, about 5% of the leaks of the sources of methane represent 50% or more of the emissions. So it's true for many different class of asset, and it's true for the distribution system. So that's the definition we are using here.
Now that we understand where the term actually super emitter derives from, can you tell me what's the difference between a super emitter program, or how is a super emitter program different than an advanced leak survey program?
Yes, actually, the difference is in the investigation practice. So when you run an advanced leak survey program, you detect the peak of methanes that are sign of a leak, and you investigate every of them in order to identify the potential leaks. With a super emitter program, the data collection is the same. So you continue to detect methane peaks, but you address only the methane peaks that have been quantified are larger than the threshold defining the super emitter program. That way, you limit the investigation to the small number of leaks that are larger in the system. And it's very important because the investigation is a costly part of the leak survey process. So by focusing on larger leaks, we get a much better effectiveness of the program.
Coming back to the 550 statement. So you're gonna abate more in the long run if you just focus on the super emitters. So Sean, let's talk for a minute about how organizations are actually deploying this type of program.
Sure. Well, the most effective way is to get started with driving and collecting as much of the data over the network as possible. And so we see operators that are covering up to 100% of their network every year, and some that are even going to a more frequent cadence, trying to cover the whole network twice a year, every 6 months.
Wow.
So once you have the data, it's really the choice of what to do with it. And Francois mentioned that there's the two aspects. There's the regulatory leak survey aspect, and then there's the super emitter aspect. So in the US, the regulations only require leak survey to be every 5 years on most asset classes. And so that means that if you drive 100% of the network, 20% of that data are being used for leak survey purposes, where every indication is being investigated in order to find all the leaks. But that leaves the opportunity on the rest of the territory. So up to 80% that you did not drive for leak survey practices, you can take advantage by only investigating the large indications. This is what we call the super emitter program. And it allows the utilities to focus on repair efforts on just that small number of leaks, the 5% that's going to make the most difference to the emissions.
That makes a lot of sense.
Absolutely. And actually, I would add that the super emitter program being a prioritization of the repair of the large leaks, it doesn't really add cost of repair, because after you pass the first year or two where you detected leaks that have been open for a number of years, you reduce the number of leaks that you find, and you are back to the repair volume that were before the application of the program. So the idea is really to prioritize the repair only on the large leaks, and by that way, accelerating the reduction of emissions from the large leaks more than from smaller leaks. And that way, you obtain the reduction without creating additional cost of repair. And that's an important aspect of the program, because of course, the major limitation is the resources. You cannot repair everything every time, all the time. So the prioritization is the way to reduce the emissions without increasing the volume of repair.
So we've talked about finding the leaks. We've talked about how we're going to abate the leaks. What does all of this mean in terms of reporting what you've done?
Yeah, so I think the advantage of the data collection at scale is all the data is available to do whatever you want to with it. And so in terms of emissions reporting or reporting the efforts of abatement programs, everything can basically be done automatically and in near real time as soon as the data are collected on the portion of the infrastructure. From there, even these methane indications can be dispatched into the field automatically. And so investigation and repair resources can be assigned and completed. And also in terms of tracking the abatement, everything can be done automatically. So operators can see the impact, the gradual impact of their abatement efforts over time, reporting on progress regularly throughout the year, for example.
Mm-hmm. Actually taking credit for the work that they're doing to abate their emissions. Mm-hmm. So we started this discussion talking about how to reach net zero. How can a super emitter program help you get there, Francois?
Yeah, and that actually go back to the definition of super emitters. And we had a definition of super emitter, which is relative and also very flexible. So the idea is starting with the largest leak in order to not overwhelm the operation and repair teams with the detections. But at the same time, preparing for the next steps. And there is nothing prevent you to define a super emitter with a lower threshold. And it's actually what PG&E is doing now by reducing the threshold from 10 to 7 cubic foot per hour, and we can continue to go down that way in order to reach a reduction that will never be zero, but in reach for the zero net, knowing that the remaining of the emissions will be compensated by offset from other programs. But that's this program allows this transition and this progressive reduction of the emission towards a very deep reduction as the ultimate goal in 10 years from now or so, depending on the companies and the organizations. But it's not a one step and it stops there. It's actually a path toward a deep reduction.
That makes a lot of sense, mapping out your path to net zero, if you will. So I want to thank everyone for your time today. Another great discussion in the books, this time on methane abatement and the importance of implementing a super emitter program sooner rather than later. We also discussed why we believe going after your biggest leaks is going to improve the most impact to your organization. If you would like to learn more on this topic and to become a linguistics expert in methane measurement or abatement solutions, visit our website, gas.picarro.com, for further reading. Up next, we will continue this language lesson by discussing another aspect of this topic, which is the more holistic treatment of methane data points and the optimization of safety leak survey schedule and what our experts recommend next. Thank you for your time.